For today's extension, we are going to look at slope and constant rate of change. So we've already looked at constant of proportionality. We're going to take this just a little bit of a step further, not just looking at when there's a proportional relationship. So linear equations have a constant rate of change. Specifically, in the word linear, we see the word line, which means they should form a straight line. So this is not a linear equation, this is not a linear equation because they are not a constant straight line. Slope, or constant rate of change, you might hear us use interchangeably. It's how one value changes in relation to another. So it is the ratio of the change in y, we can use a little delta to represent change in y, to the x, change in x, horizontal change. So if I'm writing it in a fraction form for the ratio, change in y over the change in x. So sometimes people mix this up and put x on top because they're thinking alphabetically, but it flips around. Y is on top over x. So we're going to look at finding this given graphs, tables, and points. So when we are given a graph, we're going to find two specifically clear, distinct points. I'm not going to pick like in the middle of this box here where I have no idea what it's representing. I'm going to use these clear points that are already labeled for us here or that I can find. And then we're finding the rise, which is our vertical change, over the run, which is our horizontal change. So you can technically use any 2 points here. I could use these 2 points, these 2 points, these 2 points, these 2 points. It does not matter. I try to do two that are close to each other. If you do a bigger one, you would just have to simplify, okay? So in this one, our rise is that vertical change right here to our run, the horizontal change. You technically could kind of go backwards. You could do the vertical change here and then horizontal change there, but just be careful with your negatives. So my rise, I'm counting from here. It's going up 1 box, 2 boxes, 3 boxes. So it has a rise, a vertical change of 3 over our horizontal change is 1, 2. So we have a slope of 3 over 2. So let's look at it in these graphs. So here again, I can pick any 2 points. Maybe I'm gonna pick these 2 points right here. So I'm going to find our vertical change over the horizontal change. So vertically, this is going up 1, 2, 3. Over horizontally, it's going over from the point 1, 2, 3, 4. So our slope is 3/4. If you had picked points that were further apart, let's say I had picked these 2 points, you would have gotten 6 over 8, which is the same thing. You would just have to simplify. Then again, like we talked about with constant of proportionality, when you've got a graph that has units in it, we just need to pay extra close attention to the axes and then think about the explanation part of it, okay? So when I'm looking at these 2 points, I've got my rise, which in this case is actually going down over my run, my horizontal run. When I'm looking at the rise, my axes are going up by 1, so I can count by 1. 1, 2, 3. But we're going down, so I'm gonna write that as -3. For our x-axis, we gotta be a little bit more careful because each tick mark is representing 10. We've got 10, 20, 30, 40, 50, and so on. So as I'm going over, this isn't 1, 2, 3, it's 10, 20, 30. So we get -3 over 30. And we're keeping this negative here because over here we had a positive slope. It's going up as you go to the right. Here it's going down. It's decreasing. That's a negative slope. 3 and 30 divide by 3. So this becomes -1 over 10. And then for our meaning, we got to look at our units. So our y, which is on top, is talking about the candle length in inches. Our x, which is on the bottom, is talking about the time in minutes. So I can represent this negative by using the word decreasing. So it's losing, or 1 inch lost of the candle length, right? Every 10 minutes. All right. Now we're going to talk about the 4 kinds of slopes. We've already kind of talked about 2 of them, and then we're going to talk about 2 special case scenarios. So basic slope is a positive slope. We read from left to right. So as we're going from the left side, the bottom left, to the top right, it is increasing. It is a positive slope. If this was talking about your money growth, it's going up over time. The opposite of that would be a negative slope. So we're starting in the top left and we're going down as we go to the right. So if as you go to the right, it goes up, that's positive. If as you go to the right, it's down, that's negative. So that's important to note because sometimes people will calculate, like on these problems, the correct numerical value, but we'll forget the negative because this one was negative, this one was positive. So you've got positive and negative slopes. And then we have special case scenario. So first special case scenario is a 0 slope. If you think about someone said, hey, I'm gonna go hike a mountain with 0 slope. To you, you probably think that means flat, which is exactly what it means. A 0 slope is going to be a horizontal slope like this. There's no slope, it's flat. That would be easy to walk. The opposite of that is an undefined slope. So an opposite of a horizontal flat line is going to be a vertical straight line there. The way that I remember this is if you tried to ski this mountain that's straight down like that, your body would be undefined, okay? So finding slope, constant rate of change, given 2 points or a table. Just like we did before, we're picking 2 clear points, and we're still finding the change in y over the change in x. We are just using this formula. And that looks a little fancy, but it just means that we have a point here, which has our x and y from one point, and we have our x and y from another point. So we just have x1, y1, and x2, y2. So that's just saying we have an ordered pair and another ordered pair. So it's just saying the 1s go together and the 2s go together. So the order is important there. I technically can flip these around. I could start with y1 instead of y2, but if I start with y1, I have to start with x1. If I start with y2, I have to start with x2. Okay? So number 3, we've got a table. We're gonna pick 2 of those points. I like to pick lower numbers, and in this case, we've got decimals. So I'm actually gonna pick the lowest non-decimal problems, okay? So my ordered pairs, we start with y. In the table, it goes x, comma, y. So I'm gonna pick my bigger y, which is 44, minus the other y, which is 32. All that matters here is that if I started with this y, I have to start with this x of 2 minus the other x, 1. When I subtract, I get 12 over 1, and I'm going to keep that as the fraction when I write my constant rate of change. Now, when I'm going back to think about the meaning, well, my top value is my Y. Y is talking about cost, so it's in dollars. It's $12 per. The X is talking about hours, so $12 per hour. Okay, let's look at number 4. We've got X is our left side, Y is our right side. I'm gonna pick 2 clear points here. I'm just gonna use these low ones. So I'm gonna start with my bigger Y, which is 3, minus my other Y of 0, over, starting with my X of 6, minus my other X of 4. 3 minus 0 is 3, over 6 minus 4 is 2. So our constant rate of change is 3 over 2. And what does that mean? Well, our Y is talking about the cost in toppings. So $3 every, our X is talking about number of toppings. So every 2 toppings. And then let's look at it given just some points calculating. So we're still going to use this formula, y2 minus y1, x2 minus x1. We can start with either one. I'm going to look at my y's first because that's what's going to go on top. I always like to start with the bigger y. So I'm going to do 6 minus 3. And all that matters is if I started this y, I need to start with the corresponding x. So I'm going to start with 4 minus our other x of 2. 6 minus 3 is 3. 4 minus 2 is 2. That gives us a slope of 3 over 2. Number 6, I'm going to look at my 2 y values. I'm going to start with the bigger y. So we have a 7 here. So I'm going to do 7 minus 2. Since I started with this y, I have to start with this x. 3 minus our other x of 1. 7 minus 2 is 5. 3 minus 1 is 2. So our slope is 5 over 2. Now we're going to look at our 2 special case scenarios. Find the slope of the line between 0.79 and 11.9. So, looking at my y values, they're both the same, so it doesn't matter the order that I do it in. 9 minus 9. And then I'm going to start with my bigger x, 11 minus 7. 9 minus 9 is 0. 11 minus 7 is 4. So this is a special case because it has 0 in it. If you're not sure what that calculates to, you can plug that into the calculator. 0 divided by 4 is going to give you the answer of 0. So this is a 0 slope. 0 can be divided by anything. It's just an invisible thing being divided up. It's going to stay invisible. It's 0. The second special case, let's look at our y values. We have an 8 and a 1, so I'm going to start with 8 minus our other y value of 1. Since I started with 8, I'm going to start with this 5 here minus the other one is also 5. 8 minus 1 is 7 over 5 minus 5 is 0. For this, when I plug that in, sure it's on, yep. 7 divided by 0, I get an error. Divide by 0, error. That's because it does not work. This is our special case scenario of undefined. You can't divide something 0 times. That doesn't make sense, so it is undefined. So 0 on top is 0, 0 underneath is undefined. If you're not sure, plug it into the calculator and it will tell you.